Hi, have you ever had a situation when your tests are randomly failing or tests are failing even though you didn't change the logic, the behavior of those components? If yes, then maybe your unit tests contain mistakes that I'm going to cover in this video. And good news is that when I was choosing my top mistakes, I was choosing them not only by how common they are, but also how easy to fix them, so you can immediately apply the knowledge from this video and benefit from easy wins. And as always, if it is your first time on my channel, my name is Dmitry and my goal is to help you to become an advanced Angular developer who clearly understands what they're doing and how things are really working. My channel is full of advanced and unique Angular tutorials that you can check out later. But now let's focus on the most common mistakes people do in Angular unit tests. Before we discuss top unit test mistakes in Angular, let me very quickly provide some context so you have a general idea of what is going on here. So I've got a simple widget component that displays the data provided via component input. This component has a regular select element where the user can select the time span for the weather forecast, and once it is changed, it involves the onTimeSpanChanges callback where component output timespanChange emits the value the user selected. This emitted event will be handled by the parent component, and in the dedicated handler, the widget data signal is updated according to the selected time span, and new data will be delivered back to the weather widget component via data input. Also, the weather widget handles a use case where location isn't provided and the corresponding placeholder is displayed in this case. All these three scenarios are covered by unit tests right here, so we can ensure that first of all, component renders the provided data properly. The second test verifies that if the location is missing, we should see a dedicated placeholder. And the third test asserts that when user changes the time span, the time span change event should emit a correct value. These tests contain mistakes that I'm going to show you in a few moments. And by the way, one of them is already visible. So let me know in the comments if you could immediately spot this mistake. If you need more time, you can pause this video because I'm about to start. And the first mistake is value assigning operations in the describe function. I frequently notice people declaring variables within the describe function and immediately assigning values to them, just as I did right here on this line. Usually the purpose behind this is typically to reuse those variables across multiple tests within the particular test suite, the same way as I do it here in some of my test cases. So why is the assigning operation inside the describe function block is almost always a bad idea and no-go solution? This is because the value of this variable is set only once, right before the test cases in the test suite begin to run. The variable itself is shared among multiple tests, so if one of them mutates the value of this variable, it might have negative side effects on other tests that depend on value of this variable as well. So let me demonstrate how it might look in practice. I have a unit test that asserts if the no location placeholder is visible when data for my widget component has no location provided. That's why it has been taking decision to mutate the widget testing data variable and set location property to undefined before assigning this variable to the component data property. This will work okay for this current test, but if after this one will be executed the other tests which also rely on the widget testing data variable, this follow-up test will fail because assertion rules here, they expect that location is present in the data object, but this is not true because location property was mutated by the test before, and we assign already mutated data which is not expected in particularly this test case. And if you try to run tests, the situation gets even worse because suddenly you might get no errors at all and you think that, okay, I'm safe to push my changes to my Git repo. And then when you push and your tests are running on your CI pipeline, then suddenly, boom, you get an error and you are confused what the heck, how it happened. You go and to run the same code locally and it is green again. And your verdict, okay, it was a glitch on the CI, but it was not a glitch on the CI. This was direct and dangerous consequence of assigning values in the describe block. The reason why it happens randomly is because test runners like Karma, Jest and others, they execute tests in random order and not in the order they're written in your test file. This is done exactly to make sure that tests do not affect each other. So depending on when mutation of the widget testing data variable happens, before or after this exactly test will be executed, we will get or might not get the error in our test report. Okay, so as you can see, there are a lot of negative consequences of this decision, but how to avoid them? We can solve all those problems by simply extracting the assignment operation inside the before each hook. So just like that. And this hook is executed right before running each test in the test suite. So even if the widget saving data variable is mutated by one of the previous tests, before running the next one, the before each hook will, so to say, reset the value of this variable back to the default one, which guarantees that the initial value of this variable will be the same for each test in this test suite, making your test more stable and more independent from each other. I hope I could make it clear, so we can move to next mistake, which is, by the way, it is also already visible. Can you spot it right away? No? Okay, so the second mistake is improper changing of component input values. You can often see that input values for the test component are updated by assigning a new value directly to the property of the component class instance. This approach was always wrong and caused many issues because when Angular updates input bindings the traditional way, it does much more than just simply update the corresponding class property. Among other things, the traditional input binding update also cares about input aliases. It marks component as dirty if they have on push change detection strategy and schedule ng on changes lifecycle hook. In contrast, updating component input by simply overriding class property bypasses all those things, which means that the component in your tests behaves differently from how it behaves in a normal environment in your application. Such tests are very easy to break without even touching the component logic. Just try to enable on push change detection strategy for a component to break certain tests. Or even if you don't need the change detection strategy on push in your component, sooner or later you will be migrating to signal inputs because signals, it is Angular's future, they are cooler, better, faster, prettier, stronger, nicer, and blah. Anyway, again, once you perform the migration to signal inputs, you will break your tests as well because signal inputs are read-only, which means that you will not even be able to set a new value for those inputs. And all these issues are caused by improper changes of the component input values in your test. So how to solve it? Starting from the Angular 14.1, if I'm not mistaken, The proper way to do that is using component ref of the component fixture and call the setInput method, where you provide as a first parameter the input name, and the second parameter, this is the value this input should have. And obviously I have to do it for every test case where I set new values to this data component input, right? And here we go. Once I save this change, my tests are green again, because setInput method works the same way as it happens normally through the input binding in templates. And that's why it works properly with on-push change detection strategy and or with signal inputs as well. You might reasonably ask, okay, but what if I use Angular version that is older than Angular 14.1? In that case, I would suggest you using the test host strategy. In short, the idea is that you wrap the component you are going to test with another component, so-called host component, and there you update inputs of the component you are going to test by updating the host component class properties. In this case, the direct update of the test host class property is a safe operation, because the inputs of the component you are actually testing are being updated by the normal input binding update. Okay. By the way, if the concept of test host strategy sounds unclear, or you find overall concept of unit testing in Angular quite confusing, I have a video course which was designed exactly for those who has no or very little experience with unit testing but wants to master it as soon as possible and understand how things are really working. In the video description there will be a link to this course you can check out, but we are moving forward and let's talk about mistake number 3, which is fragile query selectors. In tests, we always have to query certain DOM elements to check if they exist, read their values, or fire some events, etc. Very often class names, IDs, or even tags are used as selectors, and it can break your tests during the component refactoring even when you don't change the component logic. And the problem with these selectors is that inside your component code, they don't explicitly indicate that they are used for tests, and you or your colleagues can easily rename the CSS class name without even thinking that you break the test. Much better to use more explicit selectors based on data attribute. So you can use actually any name. I personally prefer data test ID, and simply provide some unique string as a value for this attribute, which describes purpose of this element. Then in my unit test, I select this element, but this time using this new attribute instead of using the CSS class name. So just like that. And yes, it becomes slightly longer because you need to, introduce a new attribute, but it clearly states that this is used by some of test, somehow related to test, and it is very unlikely that you will unintentionally remove this attribute or change it during the refactoring. A little improvement, but huge positive impact. Mistake number 4. Class-only tests. The classic example of such tests is when you instantiate components simply as a JavaScript class and then just call public methods manually in your test. You can also see a hybrid approach when the component is created using test-bed create component, but methods and lifecycle hooks, they're called manually, like in this particular example. I claim it as a mistake, though I know that some developers might disagree with me and they intentionally use this type of test in their project, but in my humble opinion, this kind of test isn't reliable and useful at all. And in this part, I will try to explain why I think so. For me, if we are talking about component tests, if you call manually lifecycle hooks or component methods, it is always a code smell. And in most cases, you should avoid it. Why? Because what does the current test verify? It verifies that the component output emits the selected time span when the method on time period changes is called. That's great, but users do not call component methods directly. Users invoke those methods by interacting with the corresponding UI elements, and we have to test exactly that, because currently this test gives me a false sense of confidence, and confidence because, well, it is green, and false confidence is because if I go to the component and simply remove the entire select component, my test will remain green, even though the component cannot be properly used anymore. So this test doesn't cover the entire interaction layer, which is very, very important. So when you see that some component method is manually called in your test, think about what trigger invokes this method and simulate exactly that trigger instead of calling the method manually. In my case, this method is invoked when the user changes the value of the select element, and this is exactly what I have to simulate. So in my test, instead of this manual method call, I have to get reference for the dedicated select element, right? Which, by the way, I have to bring back. So let's go and revert my previous change. Also, let's use already learned best practices and create a dedicated selector for our test so that I can query this select element using the component debug element, just like that. And now, once I have a reference to this select element, I can set the new value for the select native element, and then I can simply fire the change event by using the method dispatch event of the select native element. And yeah, inside I have to create the event instance itself. And if you save this change and rerun test again, you can see that everything remains working. But this time I don't call the method manually, and instead I invoked the same method by simulating the user behavior, which ensures me that not only event handler properly works, but also that it can be invoked by user. I think I should mention a quick remark. I'm not saying that you should never call component methods in your unit tests. If there is no clear trigger for this component method and there is nothing to simulate, then it's fine to call the component method right in the test. Mistake number 5, false positive component output testing. Let's get back to the previous test that we have a little bit improved. And very often I see people test components outputs by subscribing to the class component property and running the expectation function inside the subscribe callback. Unlike component inputs, it is not an issue, and accessing the component instance properly, it is okay. The problem here is running the expectation function inside the subscribe callback. This leads to false positive tests because if nothing is emitted, the expected function will never be called and the test will never fail. I can prove it by removing the corresponding output emission logic from the component method right here, and you can see that the test remains green. How to avoid this situation and make test fail in this case, you have to create at the beginning somewhere a variable. Then inside the subscription callback, you update this variable with the value that's supposed to be emitted by the component output. And your expectation, this expect function, you move in the very end, and here as an argument you provide this new variable. And the idea is that if the output is not emitted, the value of the expected output will not be updated. So your test will fail because undefined doesn't match your expectation. And this is exactly what you will see if you rerun tests. So my test is failing because the proper emission didn't happen. So in order to make my tests green again, I just have to revert the proper logic back. So now my tests are green again. By the way, you might be curious, what are those green squares here, or how do I see the test error message directly in the VS Code? Is this a special plugin or something like that? Yes, this is a special plugin which I would like to share with you today, and it is called WallabyJS, and it is indeed very helpful because it runs tests immediately as you type them or change them, and it brings results of your test right to your code. And after a few weeks of using it, I find it really helpful and handy, because now I can simply stop my tests in terminal, and the corresponding browser window opened by Karma goes away as well. And now I can rely only on Wallaby plugin, which can be started from scratch if you experience any issues. In some project I had some issues when Wallaby stuck, but it's not a big deal. Just simple restarting of Wallaby plugin helps. And it provides you a nice console where you can see tests which might fail and other useful data from your test report. Or if you want to have a look at some point in time what value of a certain variable in your test, you can console log it and immediately see the output. Or what about debugging tests right in your editor? It is also possible with WallabyJS. Just run the corresponding command and enjoy debugging your tests if you need. So it is indeed a cool plugin that offers a lot of cool features related to unit testing, but unfortunately it is paid. However, in the video description I drop a link using which one you can get a free trial period, during which one you can explore more features that Wallaby offers. I mentioned just few of them. Again, link will be in the video description. Alright guys, thanks for watching this video until the end. I hope this video was useful, and if so, please share it with your colleagues and friends. In such a way you can help my channel to grow and support the release of new videos like that. Also, if you're looking for the Angular community, you can join our Discord server. We are already more than 1000 Angular developers around the globe, and we're looking forward to meet you as well. Please scan this QR code and get access to our community absolutely for free. If you want to learn more about unit testing and support this channel as well, check out the video course I mentioned earlier in this video. There, I'm pretty sure you will learn quite a lot of new things. Otherwise, I wish you a productive week ahead, stay safe, and see you in the next video.